All right, so we're gonna go over how to read a chemical formula because sometimes this can be a little bit hard, but once you've got it down, you'll be able to read these pretty easily. So the first thing you need to know is that there are some elements that are called diatomic elements. Here, di means two, atomic means atom. And these guys just basically, they're so electronegative that they never spend any time alone. So if an atom happens to be unbonded, it will immediately find another one of its kind and bond together. So the oxygen we breathe right here is actually not a single oxygen atom, but instead it's an oxygen atom bonded to another oxygen. Same with hydrogen, nitrogen, fluorine, chlorine, bromine, and iodine. They're all diatomic. There are 7 of them, and they make a 7 on the periodic table plus hydrogen. That's how I remember it. But next, let's talk about symbol versus formula. A symbol is the shorthand for an individual element. It's one capital, one lowercase. So, for example, here, Pu with a lowercase u means plutonium, whereas Pu with a capital U means phosphorus and uranium. And sometimes you guys have handwriting where you can't really tell what's capital and what's lowercase, so be careful of this. But generally speaking, you want to make sure that you can clearly tell what's lowercase. Another hard one that we have is you guys will see this and you'll go, is that Ci or is it Cl? So sometimes I will write Cl for chlorine with a cursive L. And then a formula is a shorthand for a compound or a molecule. They show the number of atoms of each element. So this right here, Fe2O3, there are 2 irons and 3 oxygens. The little numbers only apply to the element that comes in the front of them. So here's some practice reading some formulas. So right here, H2O, we have 2 hydrogens and 1 oxygen. Notice that this little baby 2 does not apply to the oxygen, it only applies to the hydrogen. Here we have 1 carbon and 2 oxygens. Here we have 1 carbon and 4 hydrogens. So those are the 3 simple ones. Now we're going to get into something a little bit different. We have these big numbers in the fronts. These numbers right here are called coefficients. And coefficients mean that there are 2 of those molecules overall. So this number gets distributed to everything else inside of this formula here. So now we're gonna have 4 nitrogens and 10 oxygens here. Similarly here, we're gonna have 6 hydrogens and 3 oxygens. And then right here, 17 carbons and 34 oxygens. And then the last thing we want to talk about here are these weird parentheses ones. The parentheses ones, this little number applies to everything inside the parentheses, but not to the thing outside of it. So we only have 1 aluminum, 3 nitrogens, and 9 oxygens. Down here we have 1 magnesium, 2 oxygens, and 2 hydrogens. And then like right here we have 1 lead, Pb is lead, 2 nitrogens, and 6 oxygens. That's how you read a chemical formula. The reason we use chemical formulas is, why do I say H2O instead of just saying water, is because chemical names, especially once we get up to huge proteins, have really long names. This, for example, is actually truly a name of a protein. And that's why chemical formulas are sometimes easier to deal with. You need to know a monatomic ion. Monatomic means 1 atom. Is a 1 atom with a charge here, so like O2 minus or H plus, those are both monatomic ions. Polyatomic ions are made up of more than 1 atom and they stay in their group during a reaction. So an example here, we just looked at 2 pages ago, we had something like this. Basically what this means is that this NO3 right here is going to stay in its group if it ever goes through together, if it ever goes through a chemical reaction. So I will have a drawing here in just a second to show you that. These are the polyatomic ions that you need for my class. They are given to you on tests. You do not need to memorize them, but they may be helpful in the future. But this is my example here of polyatomic ions. If I've got 2 NH4s, that means that there's these 2 right here. They are separate from each other. They're not bonded together, which is why we wouldn't just write this as N2H8, but instead as NH42. The reason we do this is because I'm telling the chemist these are 2 separate groups that don't stick together but are chemically unique in their own way.